Isaac Newton, born in England in 1643, was an extraordinary individual. He was a physicist, a mathematician, an astronomer, a theologian, and even an alchemist. Talk about a Renaissance man. Newton's work revolutionized our understanding of the universe. He is best known for his groundbreaking work on the laws of motion and universal gravitation. Before Newton, nobody could accurately describe how objects moved. Why do things fall down? Why does the moon orbit the Earth? These were mysteries. Newton cracked the code, revealing the elegant laws that govern the motion of everything. From the smallest atom to the largest star, Newton's laws apply. His work laid the foundation for classical physics and influenced countless scientific advancements. Newton's first law of motion is all about inertia. It states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. In simpler words, things like to keep doing what they're already doing. Think about a soccer ball sitting still on the grass. It's not going to suddenly start rolling on its own. It needs a force to act upon it, like a kick from a player. Now imagine that same soccer ball rolling across the field. It's going to keep rolling at the same speed and in the same direction until something stops it, like a goalpost or another player. Newton's second law of motion tells us about the relationship between force, mass, and acceleration. It states that the acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. Sounds complicated? Let's break it down. The formula for Newton's second law is F equals ma, where F is force, m is mass, and a is acceleration. This simple equation tells us a lot. Imagine pushing a small car and a large truck with the same amount of force. The car, with its smaller mass, will accelerate faster than the truck. Think about a rocket launching into space. The engines generate tremendous force. This force acts upon the rocket's mass, causing it to accelerate upwards against the pull of gravity. The greater the force of the engines and the lighter the rocket, the faster it will accelerate. Newton's third law of motion states that for every action, there is an equal and opposite reaction. This means that whenever one object exerts a force on another object, the second object exerts an equal and opposite force back on the first object. Imagine jumping off a diving board. You push down on the board, action, and the board pushes back up on you with an equal force, reaction. This upward force propels you into the air. Every time you walk, you're using Newton's third law. You push backward on the ground, and the ground pushes forward on you, propelling you forward.